Welcome back to Educator.com. In this lesson, we're going to take care of multiplying polynomials. Specifically, we'll look at the multiplication process in general, so you can apply it to many different situations, and then really look at some more specific things, like how do you multiply a monomial by any type of polynomial, and how can you multiply two, say, binomials together. I'll also show you some special techniques, like how you can organize all this information into a nice handy table. And of course, I'll show you the nice way that you can multiply two binomials using the method of FOIL. So watch for all of these things to play a part. Now, in order to multiply two polynomials together, what you're really trying to make sure is that every term in the first polynomial gets multiplied by every single term in the second polynomial. That way, every single term gets multiplied by every other term. Now, if you have one of your polynomials, say being a monomial, it only has one term, then this really looks just like the distributive property. So let's do one real quick so you can see that it really is just the distributive property. We're going to take 2x to the fourth, that monomial, one term, and multiply it by 3x squared plus 2x minus 5. So we'll take it and multiply it by all of these terms right here. So we'll have 2x to the fourth multiplied by 3x squared. Then we'll have 2x to the fourth multiplied by 2x. And 2x to the fourth multiplied by a negative 5. Alright, now each of these needs to be simplified, but it's not so bad. We can take the 2 and the 3 and multiply them together, get a 6. And then we'll use our product rule to take care of the x to the fourth and x squared by adding their exponents together. So x to the sixth. And we simply run down to all of the terms doing this one by one. So 2 times 2 give us a 4. Then we'll add the exponents on x to the fourth and x to the first power. So x to the fifth. And now we're at the very end. So 2 times a negative 5, negative 10. And we'll just keep the x to the fourth. So this represents our final polynomial after the two have been multiplied together. So again, remember that we're looking so that every term in one gets multiplied by every term in the other one. Now, what makes this a little bit more difficult is, of course, when you have more terms in your polynomials. But again, as long as you make sure that every term in one gets multiplied by every term in the other one, should work out just fine. Let's be very careful with this one. See how it turns out. So first I'm going to take this first m cubed term and make sure it gets multiplied by all three of my other terms. So let's put that out here. So I need to make sure m cubed gets multiplied by 2m squared. Then I'll have m cubed multiplied by 4m. And m cubed multiplied by 3. Okay? Now, if I stopped there, I wouldn't quite have the entire multiplication process down. We'd also want to take the negative 2m and multiply that by all three. So let's go ahead and put that in there as well. So we'll take a negative 2m, multiply that by 2m squared. Then we'll take another negative 2m, this time multiply it by 4m. And then a negative 2m multiplied by 3. Okay, quite a bit, but almost there. Now we have to take the 1 and multiply it by all three as well. So 1 multiplied by 2m cubed. 1 multiplied by 4m. And 1 multiplied by 3. Alright, so that's a lot of work, and we still have lots of simplifying to do, but we've made sure that everything got multiplied, so now it really is just a matter of simplifying. Let's take it bit by bit. So starting way up here at the beginning, I have m cubed times 2m squared. Adding exponents, that would be 2m to the 5th. Now I have m cubed times 4m. So we'll add those exponents and get 4m to the 4th. Okay. On to m cubed times 3. So 3m cubed. And now we continue down the list over here. So negative 2m times 2m squared. Well, 2 times a negative 2 would be a negative 4. We'll add the exponents and get an m cubed. And I'll take care of that. Now we'll go to this guy. Negative 2m times 4m. Negative 8m squared. Now this one. Negative 2m times 3. Negative 6m. Alright, so that takes care of those. On to the last row where we multiplied 1 by everything. Well, fortunately, 1 times anything is itself, so I'll have 2m squared, 4m, and then 3. So I have all of my terms in the resulting polynomial, but it's still not done yet. Now we have to combine our like terms. So let's go through and see if we can highlight all the terms that are like. So I'll start over here with 2m to the 5th. And it looks like that is the only m to the 5th, so it has no other like terms to combine with. Now we'll go on to m to the 4th. Okay, let's see what we got for that. I think that's the only one, so 4m to the 4th. 3m cubed. Looks like I have a couple of m cubes, so we'll highlight those. And let's see, I have some squares, so we'll highlight those. And let's see, what else do we have in here? Looks like we have single m's. There's that one, and there's that one. And then a single 3 on the end. Okay, so we can combine all of these bit by bit. So 2m to the 5th, since it's the only one. And 4m to the 4th, since it's the only one. Let's check these off, they're done. Now I have 2m cubes. So 3 minus 4 would be a minus 1m cubed. And I'll take care of those ones. And let's see, negative 8m squared plus a 2m. So minus 6m squared. That one's done, that one's done. Minus 6m plus 4m would be a minus 2m. Done and done. And then we'll just put our little 3 on the end. Alright, you can see it is quite a process when your polynomials get much bigger. But it is possible to take every term and multiply it by every other term. Now, watch for later on how I'll show you some special techniques to really keep track of all of these terms that show up. It'll actually not be quite as bad as this one. Now, one way we can deal with much larger polynomials and keep track of all of those terms that multiply together is really try and organize all of those terms in a useful way. And I'm going to show you 2 techniques that you can actually organize all of that information. One of them will be using a table, and another one will look like more standard multiplication where you stack one on top of the other. And really what I'm trying to do with each of these methods is ensure that every term in one polynomial gets multiplied by every term in the other polynomial. So I'm not really changing the rule or doing any shortcuts, just really organizing the information in a better way. Of course, no matter which method you use, make sure you don't forget to combine your like terms at the end so you can see the resulting polynomial. Alright, so let's give it a try. I want to multiply x squared plus 3x plus 5 by x minus 4. And the way I'm going to do this is I'm first going to write the first polynomial right on top of the second polynomial. Alright, now from there I'm going to start multiplying them term by term. And I'm really starting with that minus 4 on the bottom, and I'll multiply it by all the terms in that top polynomial. Alright, so let's give it a try. First, I'll do a negative 4 times 5. So that'll be a negative 20. Then I'll take a negative 4 times a 3x. So negative 12x. Now I have a negative 4 times x squared. negative 4x squared. So that really takes care of that negative 4 and make sure that it gets multiplied by all of the other terms. Now we'll do the same process with the x. We'll take it, we'll multiply it by everything in that top polynomial. Alright, so x times 5. That would be a 5x. And notice I'm going to write that one right underneath the other x terms. This will help me combine my like terms later. X times 3x, 3x squared. And one more, x times an x squared, x cubed. So now that I have all of my terms, it's a matter of adding them up, and I'll do it column by column, and this will ensure that I get all of my like terms. So minus 20, minus 7x, minus 1x squared, and at the very beginning, x cubed. All right, so that is my resulting polynomial. Now, another favorite way that I really like to combine the terms in my polynomial is to use a table structure. And watch how I set this one up. First, along the top part of my table, I'm going to write the terms of the first polynomial. So let's see, my terms are x squared, 3x, and 5. Now along the side of it, I'll write the terms of the other polynomial. So x and minus 4. And now comes the fun part. We're going to fill in the boxes of this table by multiplying a row by a column. So this first one will take an x multiplied by an x squared. It really feels like you're completing some sort of word puzzle or something. Only I guess this would be a math puzzle. So x times an x squared would be an x cubed. X times a 3x, 3x squared, and x times 5, 5x. Okay, looks pretty good. Now I'll take the next row and do the same thing. So negative 4 times x squared, negative 4x squared, negative 4 times 3x, minus 12x, and minus 4 times 5, minus 20. You get exactly the same terms you do, using the other method, just a different way of looking at them. Now we need to go through and start combining our like terms. So looking at my x cubed, that's my only x cubed, so I'll just write it all by itself. Then I have a couple of x squareds, so I'll write both of those and combine them together. Minus 4x squared and a 3x, minus x squared. Then here I have a minus 12x and a 5x, minus 7x. And of course the last one, minus 20. Oftentimes you'll find your like terms are diagonals from each other, but it's not always the case, it just seems to be very common. Okay, so a good important thing to recognize in the very end is that you get the same answer either way. So use whichever method works the best for you and that you are more comfortable with. Alright, now that we have some good methods under our belt, let's try multiplying these polynomials again and see how it's a little bit easier. So we will take, I'll use my table method. We'll take the terms of one polynomial, write it along the top. I'll take the terms of the second polynomial and write them along the side. You'll see this will go much quicker. M cubed minus 2m1, 2m squared, 4m, and 3. All right, let's fill in the boxes. 2m squared and m cubed, 2m to the 5th. 2 times a negative 2 is a negative 4, m cubed. 1 times 2m squared, 2m squared. All right, on to the next row. 4m to the 4th. 4 times negative 2 is a negative 8m squared. And let's see what we got. 4m times 1, 4m. All right, last row. 3 times an m cubed, 3m cubed. 3 times a negative 2 is a negative 6m. And 3 times 1, 3. All right, now let's go through and start combining everything. So I have a 2m to the 5th. We'll write that as our first term, 2m to the 5th. And now I'm on to my 4m to the 4th power, and I think that's the only one I have floating around in there. 4m to the 4th power. Okay, we can call that one done. Let's see, 3m cubed, negative 4m cubed. So 2 of those I need to combine. So that will be a negative 1m cubed. And now I'm on to my squares. Negative 8m squared and 2m squared. That'll be a minus 6m squared. Minus 6m, positive 4m. So minus 2m. And the last number, a 3. So the great part is that really goes through and combines all of your like terms, and I know I got them all because they're all circled. I'm going to fix this negative 1 so it's just a minus m cubed, but other than that, I would say this is a good result right here. Alright, now some other nice techniques you can use to multiply polynomials together is if both of those polynomials happen to be binomials. Remember that they have exactly 2 terms. This method is known as the method of FOIL, and that stands for a nice little saying. It tells you to multiply the first terms together, the outside terms, the inside terms, and the last terms. And it really is a great way of helping you memorize and get all of those terms combined like they should. It also saves you from creating a large structure like a table when you really don't have to. So let's see how it works with this one. I have x minus 2 multiplied by x minus 6. So I'm going to take this bit by bit. The first terms in each of these binomials would be the x and the other x. So let's multiply those together. That would give us an x squared. Then we'll move on to the outside terms. So by outside, that would be the x and the minus 6. So we'll multiply those two together. Minus 6x. All right, continuing on. We're on our inside terms, so the negative 2 and the x. They need to multiply together. Negative 2x. And then our last terms, negative 2 and negative 6. Positive 12. So we really do get all of our terms by remembering first, outside, inside, last. Now, with this method, oftentimes your outside and inside terms will be like terms, and you'll be able to combine them. And this one's no different. They combine to be 8x. Once you have all of your terms, feel free to write them out. So this is x squared minus 8x plus 12. And really, the more you use this method, it'll really come in handy for factoring a little bit later on. All right, let's try out our FOIL method as we go through some of these examples. So here I want to multiply the following binomials. 5x minus 6, all multiplied by 2y plus 3. So first I'm going to take the first terms together. That'd be the 5x and the 2y. So 5 times 2, that would be a 10x times y. And that's as far as I can really put those together since they are not like terms. Outside terms, that'd be 5x and the 3, or 15x. On to inside terms. Negative 6 times a 2y, negative 12y. And the last terms. Negative 6 times a 3, negative 18. Okay, so we got our first, outside, inside, last, and it looks like none of these are like terms, so I'll just write them as they are. So 10xy plus 15x minus 12y minus 18, and we will call this one done. Okay, let's try another one, and this one you'll see has a few more things that we actually can combine. We're going to multiply a minus 4y plus x, and all of that will be multiplied by 2y minus 3x. Okay, starting off with our first terms. I'm going to highlight them in a different way. So minus 4y multiplied by 2y would be a minus 8, then y times y would be a y squared. So that takes care of our first terms. Now we'll do our outside terms. So minus 4 times a minus 3 would be a positive 12, and then x times y. Okay, on to the inside terms. X times a 2y, so plus a 2xy. Alright, and of course our last terms. Minus 3x squared. Okay, now that we have all of our terms, notice how our outside and inside terms, they happen to be like terms, so we'll put them together. This will give us our final polynomial. So 8y squared plus 14xy minus 3x squared. And now we can say that this one is done. All right, one more example, and this one's a little bit larger one. In fact, the second polynomial in here is a trinomial, so we will not be able to use the method of FOIL. That's okay. We'll still be able to multiply it together, but I'll definitely use something like a table to help me organize my information a little bit better. Okay, so along the top of this table, let's go ahead and write our first polynomial, x and a minus 5y. Then, along the rows, we will put our second polynomial. So I have an x squared, a minus 2xy, and a 3y squared. Okay, now comes the fun part. Just fill in all of those blanks by multiplying a row and a column. So x squared times x would be x to the third. X squared times a minus 5y minus 5x squared y. Okay, on to the next row. Negative 2xy times x. Well, the x's, we can put those together as an x squared and then a y. And then the last part here, negative 2xy times a minus 5y. Let's put the y's together. So negative 2 times negative 5, positive 10xy squared. Very nice. Okay, one more row. 3y squared times x. 3xy squared. Okay, it looks good. And now I have 3y squared times a minus 5y minus 15y cubed. Alright, so we have all of our terms in there. Now we really need to combine the like terms. Let's start here in the upper corner. Do we have any single x cubes that we can put with this one? Well, looks like it's all by its lonesome. So we'll just say x cubed and call it good. Okay, now we're looking for x squared y terms. So they must have an x squared and they must have a y. And I think I see two of them. Here's one. And here's that other one. So let's put these together. Minus 2 and a minus 5 would be a minus 7. And they are x squared y terms. Okay, not bad. Continuing on. I have an xy squared. I have two of those, so let's put them together. So we'll take this one, and we will take that one. So 10 plus 3, that would be 13xy squared. All right, that takes care of those terms. And one more, minus 15y cubed. We'll put it on the end, minus 15y cubed. So now I have the entire polynomial. Remember, at its core, when you multiply polynomials, you just have to make sure that every term gets multiplied by every other term, and really use these techniques such as FOIL or a table to help you organize all of those terms. Thank you for watching Educator.com.